scratch for the task of sentiment analysis. For this video, we'll be using TensorFlow, which is a very popular deep learning package, and we'll be using the IMDb dataset, which is a dataset of movie reviews. So let's get started. First, I'm using this this notebook on the cloud. If you can get a similar notebook by going to colab.research.google.com. It's basically a Jupyter notebook that you're familiar with. You can also do this on your own laptops or desktop computers. So first, we'll import TensorFlow as TF, which is traditionally done. And then I'm also going to import this TensorFlow datasets package called TFDS. If you don't have it, you may need to install it, but it gives us a few extra things that helps us clean and encode the dataset. And because Ben has already gone through some of the pre-processing steps, we don't have to repeat that content, but you probably, just to save time, but you probably have to do that for your own, for the Kaggle dataset. Next, from the TFDS dataset, we load the IMDb reviews to these two variables, and we can actually see what those are. I'm just gonna press Shift Enter. Then we can see, for example, the info. Let me type that right. So inside info, you can see what the dataset, some of the details about the dataset, the description, large movie review dataset, binary sentiment classification. You can see there's a test set of 25,000 examples and a train set of 25,000, and we'll ignore the unsupervised part because we're doing supervised learning. It also includes the text and the label. It also includes an encoder that basically has done the pre-processing and that is able to convert a text into a set of numbers. Because as probably Ben mentioned, and basically neural networks can only deal with numbers. So we basically need a way to convert each text into numbers. I'll go through an example of how this is being done, but you may have to implement this for your own network some other way. So the encoder, so this encoder stores basically 8,000 words. So it breaks down each sentence into 8,000. One of 8,000 substrings or tokens. So for example, we can see that if we have a sample string called Microsoft Student Accelerator is cool, we can get that encoder to encode that into a set of numbers. So if we run this, we get this encoding, which we can see actually here what the encoding does. So for example, 65151 is basically the token MIC, and all these tokens. So basically, this sentence gets converted into these tokens that are seen here, because there's only 8,000. The vocab size is 8,000, so obviously not every word is in the dictionary. So it's parts of words gets encoded in differently. So if we do put the encoded string back into, it also comes with a decoder, so we can easily decode those numbers back into the original string by passing it through the encoder decode function. So by passing these numbers, you can see we got our original text back. So then we are going to get the train and test data sets we're just going to extract them, which are stored in these two variables. and that is going to be fed into the neural network. So the next step is to build the actual neural net. So we are using a sub package, I guess, on TensorFlow called Keras that makes things quite a bit easier to build these neural nets. There are a few things in this network we'll be creating. So first, there's an embedding layer, which I will talk about soon. And then you can see this LSTM, which is a type of recurrent neural network, and I will get into that soon. And dense is basically a fully connected neural net. So the first things first, the embedding. So basically, each piece of each sentence gets converted into these tokens, and there are multiple ways to encode these. One of the ways is one hot encoding. So basically, you can think of it like this. So the entire dictionary can be on. So each index in a vector, which is this list of numbers, would correspond to a word. So in this case, one of the 8,000. So you can see here this dictionary, this vocabulary only has 1, 2, 3, 4, 5 words, and each of the words in the sentence gets encoded. So the gets the one here, and the cat, etc. So you get the idea. That's one way of encoding it. So when we feed into the model, it actually takes something like this. And what the bad thing about one hot encoding is it doesn't capture the relationships between the words. So one of the ways of capturing more of that relationship is to map this into an encoding high dimensional embedding space. It's basically equivalent to calculate the distance between vectors, and if you do that, you should be able to see that some similar words have a closer distance than completely different words. There is if you do want more information about these embeddings, you can Google stuff like there's one of the more popular algorithms to do this is called word2vec. So you can see that in cases like this, you can actually do mathematics with these embeddings. So for example, the relationship between king and queen will be in this embedding space might be similar to the relationship between the vector for man and the vector for woman, for example. And there are sort of like relationships that this higher embedding space is able to capture. So that's what that embedding layer does, is basically gets these one hot encoder vectors and converts it into a 64 numbers. And that gets trained from scratch when we train the network. So it learns the relationships between words or between tokens. The next layer, talk about recurrent neural nets. Recurrent neural nets are a special type of neural network that basically, instead of, so previous neural nets we talked about has an input and then a series of hidden layers and then an output. But in a neural net, recurrent neural nets have a sense of time. So so recurrent neural nets deal with sequences, and because text is a very natural sequence, it's a very good candidate for using recurrent neural nets. So in recurrent neural nets, you have so at each time step you feed in a token, and then that creates a hidden representation in the hidden layer that, together with the next input, is able to combine with the next input to give the output. So at each point there will be an output as well. Um, I'm not doing the greatest job at explaining this, but I will point to some resources. Especially this one is a generally good resource, and I will point a few more videos that will be able to explain recurrent neural networks in a bit more detail. So recurrent neural nets have a few problems with them. There's that they're not able to remember a lot of details because they can forget pretty easily. So there's a variation of recurrent neural nets called long short-term memory networks, because these the vanilla neural nets, the LSTM networks are able to perform much better than the traditional recurrent neural nets. So those are recurrent neural nets. And just on a side note, in the world of NLPs, there are more complicated uh, architectures than recurrent neural nets that are becoming popular recently. One specifically noting transformers, and you may have heard things like GPT-3 and BERT. These are a few names of other networks, and those are based on a general transformer architecture, which is quite a bit more complicated than even this. So I won't be going through that, but just haven't. But this is a good place to start with NLP and sentiment analysis. So in our network that we are building, it is also useful because this bidirectional thing that we are building in this network. So normally recurrent neural networks only go from left to right. So the LSTM, it goes in order of the words, the inputs, but it is also possible to have another network, so the after it goes through these LSTM networks, there is a dense network, which is a normal, fully connected, or you may have a traditional neural network. So basically, these word embeddings go through these two LSTM recurrent neural nets. So each token goes in here, and then the outputs from the LSTM gets concatenated together, which means added together. Like, is this movie review in this case, a positive review or a negative review? How positive or negative is that review? Yeah. So that is in this case we've built we've defined what the model should be. So we will be using this model in the next steps. I will point you in the direction of some better resources if you want to learn a bit more about LSTMs. And in the assignment, you can actually use more complicated BERT and transformer type models as well. But make sure you do understand what they're doing. In this cell, I'm actually we're just shuffling the data, and we're also adding padding, because not all our sentences or movie reviews are the same length. So we can basically, this padded batch is basically creates from the trained data set. It pads each of these movies so they're a constant length, which makes the training process easier, and it converts each into a batch size, in this case of 64. And this buffer thing, don't worry too much, but if it's a huge data set, it's hard to shuffle the entire thing at the same time. So then we have to compile the model that we just built, and the loss function here is the, so we have, so the label is either, it's either positive, it's a binary problem. So the output is 1 if it's a positive review, I believe, and 0 if it's, or negative if it's a a negative review. So what we're dealing with a binary problem basically. So that's why we're using the binary cross entropy loss. There is and then the optimizer, I did go through it in the previous video about the loss, the maths of why you would use the optimizer, but it's basically to improve gradient descent, and Adam usually works pretty well. And we're dealing in terms of metrics, we want to capture the accuracy metric as well. And then we have to fit the model, so we run model.fit on the trained data set. And in this case, we're just running for 10 epochs, and we provide the validation data set as well here. So I won't run it here, but basically you can see so at the end of the training, you can see that the final test loss and the test accuracy is in the order to a specific. For example, we can put the sample text. This is just helper functions that we will use in here. So we can see what the output for this movie review is. The movie was not good, so the animation and the graphics were terrible. I would not recommend this movie. So you would expect this to have a negative sentiment, because apparently the movie was not good. Negative sentiment. And you can plot things like this. So you can increase the size of the network sometimes works, but generally you can introduce things like dropout and other regularization techniques to prevent this overfitting. But basically, congratulations, you've now hopefully built a network. So this is how you can build one from scratch. And in the assignment, in the Kaggle competition, you can build a LSTM based neural net with TensorFlow or one of the other packages. You will have to do more text processing on the data set that we have given you in the Kaggle competition, but we'll be around to help out in case you need, and you will hopefully see you at the presentation.